Hey everyone, and welcome to section 3.2 about the slope of a line. What I want to do in this video is build our intuition about what slope means. So suppose you have three lines. There's the brown one, there's the green one, and there's the purple one. If you had to walk on any of these three lines, then the brown line would be the easiest to walk on because it's completely flat. The green one would be uphill a little bit, and the purple one would be pretty steep. Okay, so this idea that some lines would be steeper than others to walk up is really the whole idea of slope. So let's look at the definition. The slope of the line is defined by the following equation. M for slope is equal to the vertical change of the line divided by the horizontal change. Another way of saying this is the rise over run. So let's imagine that you are trying to leave a building and you have three different options of how to get to the next building. Any of these three paths, A, B, or C. Each of these three paths leaves from the same point, at least as far as the side of the building is concerned. And further, let's suppose that each of these three lines goes to the same other building. Although they'd be at different locations vertically, horizontally, you're at the same location when you arrive at the building. So what we've done here is traveled the same amount of horizontal distance from the first building to the second building. And what we're going to do is compare the altitudes of where we are after traveling on each of the paths. So for the green line, we experienced some vertical change, right? We started here and we ended a little bit higher up here. For the brown line, we experienced no vertical change. Okay, we started on the ground and we ended on the ground, supposing that the ground is perfectly flat. But it is on this purple line that we experience the largest vertical change. We start here on the ground, and by the time we make it to the other building on the purple line, we are way higher up than we were when we started. So these three lines give us varying degrees of vertical change. And vertical change is the numerator of this fraction for slope. The horizontal change was kept completely the same. The only thing that's changing here is the vertical amount. That gives us some way of ordering the slopes according to the formula. And so we get that the slope of line C, where we had no vertical change, must be less than the slope of the green line B, because there was no vertical change compared to some vertical change. And we can see from the picture that I'm going to have the largest vertical change of all when I travel on the purple line. One other thing to point out is that the brown line, having no vertical change whatsoever, would give me a numerator of 0. And we know that when we divide 0 by anything that isn't equal to 0, because here it isn't, we get 0. So the slope of the brown line is going to be equal to 0. All right, so let's figure out how to find the slope of a line from its graph. So here we have our line, and we want to know what the slope is. What we're going to do is try to find 2 points where the coordinates are going to be integer values. That's just going to make it a lot easier to tell what the horizontal and vertical change is. To find points with integer coordinates, all we have to do is find some instances where the line runs exactly into the corners of one of the grid squares. So I see here is such an instance, and here as well. So now what we're going to do is measure the horizontal and vertical change. So from this picture, this little triangle here, I can see that my horizontal change is 9. That is, I moved 9 spaces to the right. And my vertical change is then 4. So, to calculate the slope, we just take the vertical change divided by the horizontal change, and we'll leave it as a fraction. So that's not too bad. So I want to find the slope of the line from its graph, and again, I just want to choose coordinates that are going to be integers. And then I'm going to count the horizontal and vertical change. So my horizontal change here is 11. And my vertical change is 3, but I didn't go up 3, I went down 3. And on the coordinate axes, that means that my vertical change was actually negative. So m, the slope being the vertical change divided by the horizontal change, would be negative 3 divided by 11. So what's interesting about this line is that the slope is negative, and you can see that it's headed in a different direction than the previous line. So that's kind of how you can keep things straight in your head. A positive slope means that if you move to the right, you're going uphill, and a negative slope means that if you're moving to the right, you're going downhill. All right, so let's summarize a little bit. If I have a positive slope, then I'm going up and to the right like this. If I have a negative slope, like the example we just did, I'm going down and to the right, or up and to the left. A zero slope would be like that brown line in the beginning of the video. That is, it's completely horizontal. So positive, negative, 0, that covers all the different kinds of numbers that we can have, but there's one more kind of slope to watch out for, and that is the undefined slope. This is in some sense like infinite slope, because with no horizontal change, you're moving up an infinite amount, but we really just call it an undefined slope. And what kind of lines have undefined slope? It's the vertical lines. And that about wraps it up for this video. In the next video, we're going to be talking about how to actually use this to graph.